Okay, so for this problem, you're given the function g has derivatives of all orders and the Maclaurin series, which means what? No a, or a equals 0. Here is your general term and a few of the first terms. It says use the ratio test, determine the interval of convergence. Have we had a problem that actually asked you for interval of convergence before?
I don't think so.
No, what were we asked for before? The radius. So this is kind of an important problem. Anytime you're asked for an interval of convergence on the AP exam, just remember you're going to have to check for endpoint convergence once you get the interval of convergence. So that's why it's important that I go through this problem for you. All right. So I'm going to go ahead and get started with my ratio test. A to the n plus 1 all over a to the n. Can you see that okay? All right. So we're going to take the original n plus 1, everything that has an n. And I'm going to go ahead and I'm going to flip the guy right away. Instead of doing, I'm going to try to save you some time. So you know that a sub n goes here. So just let's go ahead and flip it to save time. And if you don't know that, it's going to be a long week for you. Okay, so doing some, this is 2n plus 2 plus 3, which is 2n plus 5. And in the top, that exponent becomes 2n plus 2 plus 1. That becomes 2n plus 3. So that's going to help us when we go to the next step and we simplify. All right, so from these ones, I'm left, or sorry, the minus 1, I'm just left with minus 1 to the first power. This one and this one, I'm left with x squared. And then I have the 2n plus 3 in the top and 2n plus 5 in the bottom. And like we've been doing, we're going to take anything that does not involve n and move it out front. How many people find this to be boring now because you gotta get it? I hope so. Huh? Okay. Now, because n is going to be super large, what is this limit doing?